now let's get down to the basics here. So we have our variables. Our variables are still M and V. So molarity versus volume. Molarity had to do with concentration. Volume has to still do with an amount, okay? Now, one thing that we had previously was that I said, okay, you can't leave it in milliliters. You got to change things to liters. Well, change in plan, we're going to go ahead and I'm going to allow you guys to leave things in milliliters. The thing to pay attention to is that if you have one in milliliters, one in liters, you've got to change one of them. They have to be in the same unit. That's the only thing. Just make sure that you are either dealing with all milliliters in these kinds of problems, so all ml, or all liters. You can't have a mixture. That's my only warning, okay? Everything else, though, should be pretty straightforward. We're still looking for the same units, which is our liter idea and our molarity idea. So let's dive into this first example. It says, example 1, a beaker contains 150 milliliters of 3 molar HCl. If you add water to it to make 300 milliliters, what would its new molarity be? Wow. All right, so lots of numbers here. So my recommendation, you read it slow, put the numbers that are talking about the same container together. So looking here, is that a beaker contains, so it's saying a beaker, and then it said 150 milliliters of 3 molar HCl. So that means that I have 150 milliliters of this solution. So underline that. Those two things are talking about substance 1, okay? If you add water to it to make a 300 milliliter solution, so let's put a squiggly underneath that one. What would its new molarity be? So this is now talking about another beaker. So basically what we have here is we have beaker number 1 versus beaker number 2. Okay, we're talking about a before and after. Beaker number 1 is usually a very concentrated solution. Beaker 2 is usually a very diluted solution. So we kind of start adding water to dilute it down, okay? All right, another way that we name these is that the beaker 1 is going to be your stock solution. So above M1V1, go ahead and put the word stock. A stock solution is a very concentrated solution. So as a chemistry teacher, I have to take stock solutions and dilute them so that we have different chemicals for all of our labs. I have to make sure I make the right amount for the number of students that I have, and I have to make it the right molarity for safety reasons and for it to react the correct way. Okay, so stock solution is where we grab from, the concentrated one. Your diluted solution, I think you can probably fill in the blank yourself. All right, diluted means we watered it down. Okay, so that's what 1 versus 2 means. Beaker 1 versus 2, and I'm actually going to make this just a little bit higher because it means that you're increasing that volume of solution and it's getting lighter in color. All right, so back to our example 1. We're just going to write out our givens real quick. So we have 150 milliliters and 3 molar. So what is my first molarity, or what is the molarity of my stock solution according to those two numbers that I just said out loud? No. Other one. No. A 3. It's a 3 molar. That is molarity number 1. All right. Our volume 1 is going to be the 150 milliliters. So we're going to go ahead and write 150. Okay. Molarity 2. Do we know what molarity 2 is? No, that's what we're solving for. So let's go ahead and put a question mark. Volume 2. What is volume 2? What is that final volume? 300. There we go. Okay. All right. So with this information, we're going to go ahead and plug into M1V1 equals M2V2. Now, I told you, me as a teacher, I use this equation all the time, but really, you guys are going to be using this equation or a version of it when we get into the next chapter. So you really do need to get comfortable with this equation and the algebra steps that it's taking to solve it, okay? And keep it simple. Just get yourself into a routine as you start practicing. All right, we're just going to plug in for each of these variables. So I'm going to have 3 times 150 is equal to, we're going to leave M2 a variable, meaning that we're just going to leave it a letter, and we're going to multiply that by 300. So just like we were doing before, when we were just straight up thinking about algebra, we multiply the two together, we simplify it, right? So we're going to multiply the ones that don't have letters. So I'm going to go ahead and go 3 times 150. And when I did that, I got 450. So I'm going to say 450 is equal to, and then I'm going to have this m times 300. Okay, m times 300. At that step, we're now solving for m. So the best way to do that is we take that number and send it away. What kind of math did we do to send this one away? Division or subtraction? It's not subtraction. It's going to be division. Look up here. What did we do up here? We divided. You divided away. Biggest mistake people are making is they like to subtract it, okay? So we have to do opposite of whatever is going on. So in this one, they're being multiplied. The opposite of multiplication is we're going to divide by 300. Okay? That makes these cancel out. Just kind of like when we were doing stoichiometry, I said word over word, those canceled out. That's why we did stoichiometry the way that we did. Words down to the right to cancel them out. All right, so what this looks like, because I'm realizing that diagonal, it doesn't look as pretty. This is me saying 300 over 300. And that usually is pretty clear that, oh, they canceled out to be the number 1, right? So here, these guys are canceling out. This one we're going to actually type in. So 450 divided by 300. And we're going to get the number 1.5 is equal to m. And that's your final answer. Okay? 1.5 is equal to m. Please, please, please try to remember to put your units after your numbers. So me leaving it this way was not very good. We should have put 1.5 m. Okay? Is equal to m2. All right. I'm going to skip example 2. Let's go down to example 3 real quick because it's pretty similar to what we just got done doing. So you guys should feel a little more confident on it. Okay, example 3 says a beaker contains 50 milliliters of 0.5 molar KOH solution. So these two are talking about beaker 1, just like we were talking about earlier. Okay, so these two numbers are talking about the same thing. What would the new molarity be? So I squiggled it. Of the solution if you add water to make the total 125 milliliters. So now that we've kind of decided which numbers are going together, let's go ahead and write out our givens again. Okay, so I'm going to go ahead and say, all right, M1 is equal to, so ring this part, which one of those two numbers, 50 or 0.5 is my M1? 0.5, 0.5. Who is my volume one? 50. Good job. Okay. Molarity 2, do we know what it is? Oop, nope. We don't, right. We're going to solve for that one. But we do know what volume 2 was, which was 125. Oop, I forgot the 100. There it is. All right, so we have all of our givens. We're going to plug into our M1 V1 equals M2 V2. Okay, so I'm just going to go ahead and take my 0.5, multiply it by 50 is equal to M little 2 times 125. Okay, so once again, we're going to take what doesn't have a letter next to it, and we're going to multiply those to simplify that side. So I have 0.5 times 50 to get the answer 25. I'm going to set that equal to M2 times 125. Okay? Does everybody know what the dot is, by the way? That it's multiplication? Okay. Just want to make sure. All right. So we now have this situation. So once again, we're solving for M2. So we need to get our number away from it. So we're going to do the opposite of multiplication, which is division. So we're going to divide both sides by 125. So these will cancel out. And then 25 divided by 125 will get me 0.2 molarity is equal to M2. Okay? Not too bad? We're okay? Awesome. So the last example that I was going to run through with you guys is example 2. It's because there's one extra little thinking step on it, okay? It's the same process. You just got to make sure you read the questions carefully, okay? So for example 2, it says a beaker contains 150 milliliters of 12 molar HCl. So we have our volume 1 and molarity 1, right? So here's our volume 1. This is molarity 1. How much water should I add to it to make a 3 molar solution? So here's my M2. So we need to solve for volume 2. Thank you. Sorry. Okay, so once again, volume 1 is 150. Molarity 1 is 12. 3 molar is our M2. So we're solving for volume 2. So when we go to plug this one in, okay, we have our M1V1, M2V2. So I'm going to go ahead and say 12 times 150 is equal to M2 times, oops, my bad. We're going to have 3 times V2. There we go. All right, so once again, we are going to solve for our letter. We're going to simplify this side of our equation. So we have 12 times 150 to get the answer 1800. Okay, so I'm just going to give myself a little room up here. 1800 is equal to 3 times V. We're going to solve for V by dividing both sides by 3. Divide by 3, divide by 3. These cancel out. This one turns into 600. So we know that 600 is our volume 2. However, that is not our final answer. And that's what this whole part is saying right here. So you can definitely read that on your own. But what we're solving for was how much water did that mean that I had to add? So if we draw out our little picture, pictures always help, by the way, okay? We would say, okay, when I started out, so M1V1, I knew that I had 150 milliliters of my solution. I brought it to be 600 milliliters. So we started out at 150. We brought it all the way up to 600. The question is asking, how much did you add? So how can we figure out that answer? We want to know how much did I add to it to make it a total of 600? What would you do? Subtract them, exactly. So we're going to take that 600 and we are going to subtract what we started with, which is 150. So our final answer is actually 450 milliliters added. Okay? So that's the only thing that changed here, is that you just had that one extra little thinking step. So what I need you guys to do right now is go ahead and get out that homework page that you guys were working on with the molarity calculation. Okay, molarity calculation. We're going to flip it over to the side that says dilutions practice. You're welcome. So we're going to flip it over to the side that says dilutions practice.